Did you know NASA's XEMU spacesuit costs so much that for the price of one, you could buy more than 1,000 regular scuba diving suits? While that might sound extreme, the difference between spacesuits like NASA's XEMU and Russia's Orlan MK highlights how space agencies balance technology and cost. The Orlan MK, used by Russian astronauts for decades, is a model of cost efficiency, while NASA's cutting-edge XEMU pushes the boundaries of innovation for future Moon and Mars missions. Today, we're going to compare the cheapest spacesuit with the most expensive spacesuit ever made. The Russian Orlan MK spacesuit, designed by Roscosmos, stands as the world's most cost-efficient spacesuit, making it a practical choice for extravehicular activities on the International Space Station. The Orlan series has undergone constant evolution since its introduction in the 1970s, reflecting Russia's commitment to space exploration with a focus on affordability and utility. Unlike other spacesuits, such as NASA's Extravehicular Mobility Unit, the Orlan MK has been continually refined, leading to significant cost savings while maintaining operational reliability. The Orlan series was first introduced in the Soviet space program in the early 1970s. Over the decades, Roscosmos has consistently updated the design, resulting in multiple iterations like the Orlan D, Orlan M, and finally, the Orlan MK. Each version improved the previous one, incorporating lessons learned from actual missions and adapting to the specific needs of Russian cosmonauts. The Orlan MK variant, in particular, has been optimized for EVAs on the ISS, offering durability and ease of use while keeping development and operational costs significantly lower than other spacesuit programs. One of the reasons for the Orlan MK's lower cost is its pragmatic design philosophy. Instead of focusing on pushing the boundaries of advanced technology, Roscosmos opted for proven, reliable systems that could be mass-produced with cost efficiency in mind. This approach has allowed the Orlan MK to remain one of the most affordable spacesuits in use today, while still being robust enough to handle the demanding conditions of spacewalks. The Orlan MK spacesuit features a simple yet effective design, prioritizing durability over cutting-edge advancements. It's a semi-rigid suit, which allows astronauts to don and doff it relatively quickly. This feature is especially useful during emergency situations on the ISS when astronauts need to perform urgent repairs. The suit weighs approximately 100 kilograms, which makes it heavier than some of its modern counterparts, but it offers adequate protection and mobility for spacewalks. Each suit is rated for up to 10 spacewalks before requiring significant maintenance, making it a durable and long-lasting option for EVAs. Furthermore, it provides life support for up to 7 hours, giving astronauts ample time to perform their tasks outside the ISS. In terms of design, the Orlan MK is built to be reliable without unnecessary complexity. This pragmatic approach is why the suit remains so cost-effective. The simplified life support and cooling systems have fewer failure points compared to NASA's more advanced suits, which reduces the overall risk during missions and extends the life cycle of each suit. One of the most significant advantages of the Orlan MK is its cost efficiency. The suit is estimated to cost around $12 million per unit, a fraction of the price of NASA's XEMU or other advanced spacesuit models. This affordability stems from several factors, including the use of lower-cost materials and the fact that Roscosmos has been able to refine the suit over decades of iterative improvements. Roscosmos has also managed to keep production costs down by focusing on gradual improvements rather than radical redesigns. This continuous innovation approach has allowed the Orlan suits to evolve incrementally, ensuring that they remain effective while avoiding the high R&D costs associated with designing entirely new spacesuit systems. While the Orlan MK excels in cost-effectiveness and reliability, it does have some limitations. Its design, while durable, lacks the advanced mobility and flexibility that NASA's XEMU offers. For instance, the Orlan MK's joint mechanisms are more rigid, which limits the astronaut's range of motion during spacewalks. This can make tasks that require fine motor skills or extensive physical effort more challenging. Additionally, the Orlan MK does not include some of the more advanced features found in NASA's suits, such as dust protection, which is critical for lunar missions. The suit was primarily designed for use on the ISS, where it performs exceptionally well, but would likely face challenges in more demanding environments like the Moon or Mars. The NASA Exploration Extravehicular Mobility Unit is the most advanced and expensive spacesuit ever developed. It's a key component of NASA's preparations for the Artemis program, which aims to return humans to the Moon by 2025 and lays the foundation for future missions to Mars. Building on decades of experience with spacesuits used in the Apollo and Space Shuttle eras, the XEMU incorporates cutting-edge technology to ensure that astronauts are equipped for long-duration missions in harsh extraterrestrial environments. The XEMU is the latest evolution of NASA's extravehicular activity systems. NASA's been designing spacesuits since the Apollo missions, where the first extravehicular mobility unit suits were used to allow astronauts to walk on the Moon. Later versions were employed during Space Shuttle missions and on the International Space Station. These experiences have heavily influenced the XEMU's design, as NASA sought to improve upon the capabilities of earlier models to meet the needs of future lunar and Mars missions. The XEMU is a significant departure from the original EMU used in the Apollo program. While the Apollo suits allowed astronauts to perform limited tasks on the lunar surface, the XEMU is designed for a much more diverse range of activities. It can withstand harsher environments, including prolonged exposure to lunar dust, extreme temperatures, and radiation, all while offering greater mobility and safety than its predecessors. One of the standout features of the XEMU is its enhanced mobility. NASA has developed a new suit design that improves joint flexibility, making it easier for astronauts to move, bend, and work out during spacewalks. The XEMU uses lighter, more flexible bearings and joints, which minimize the effort needed for movement. This is a crucial improvement, as previous spacesuits often restricted astronauts' ability to perform tasks like bending down to pick up objects or moving quickly across uneven terrain. The XEMU also incorporates advanced dust protection, a vital feature for lunar exploration. Lunar dust is highly abrasive and can damage equipment and pose health risks to astronauts. To mitigate this, the XEMU includes integrated dust-resistant materials and seals designed to keep the suit clean and functional even after prolonged exposure to the lunar surface. Additionally, the XEMU features improved life support systems. These systems include more efficient cooling mechanisms, which help regulate the astronauts' body temperatures during spacewalks. Extended battery life and robust oxygen supply systems allow astronauts to stay outside the spacecraft for longer periods, which is essential for both lunar and future Martian missions. The XEMU is estimated to cost between $15 and $25 million per suit, making it the most expensive spacesuit ever developed. The high cost is primarily due to the extensive research and development that has gone into its creation. NASA has invested in designing a suit capable of supporting long-term human exploration of the Moon and Mars, environments far more hostile than low Earth orbit, where current EVA suits like the EMU are used. The cost is also driven by the materials and technology used in the XEMU. For instance, the suit's dust-resistant components, advanced life support systems, and enhanced mobility features all contribute to its high price. While the cost per unit is significantly higher than the previous suits, NASA expects the benefits of the XEMU to justify the investment, particularly as humanity looks towards deeper space exploration. The XEMU is designed for long-duration missions, making it far more capable than earlier spacesuits. One of its key features is its superior mobility. Astronauts will be able to walk, bend, and move more naturally, which is critical for exploration missions. Previous spacesuits often restricted movement, making simple tasks like picking up objects difficult. The XEMU solves many of these problems by incorporating improved bearings and joint designs. The gloves, another critical part of the spacesuit, have been redesigned to provide greater dexterity. In earlier suits, astronauts struggled with delicate tasks, as their gloves were often bulky and rigid. The XEMU addresses this by including gloves with better grip and flexibility, allowing astronauts to handle tools and equipment more effectively. Finally, the XEMU is designed to support long-duration extravehicular operations in extreme environments. Its advanced life support systems, including more efficient cooling and thermal management, ensure that astronauts can stay outside the spacecraft for extended periods. This makes the suit ideal for future missions on the Moon and Mars, where astronauts will need to perform complex tasks in harsh environments. If we compare the most expensive spacesuit to the cheapest one, the Russian Orlan MK is a model of cost efficiency, thanks to its simplicity and incremental improvements over decades. Each suit costs around $12 million, making it the most affordable spacesuit for routine extravehicular activities. Roscosmos kept production costs low by refining existing technology rather than investing in radical new designs. In contrast, NASA's XEMU comes with a price tag between $15 and $25 million. The higher cost of the XEMU is justified by its advanced design and cutting-edge technology, which are essential for more ambitious missions like lunar exploration under NASA's Artemis program and future Mars missions. The Orlan MK spacesuit, while effective for ISS operations, is heavier and less mobile compared to the XEMU. Its semi-rigid design limits the astronaut's range of movement, particularly in tasks requiring fine motor skills. The XEMU, however, offers superior mobility due to lighter materials and more flexible joint bearings, allowing astronauts to move more naturally on the lunar or Martian surface. This increased flexibility is crucial for longer missions in more challenging environments. In terms of technology and safety, the XEMU far outpaces the Orlan MK. The XEMU includes advanced features like lunar dust protection, a critical upgrade for upcoming moon missions, as well as enhanced life support systems with better thermal management and extended battery life. The Orlan MK, while reliable, lacks these modern advancements and is more suited to low Earth orbit operations where environmental hazards like lunar dust are not a concern. Looking ahead, future spacesuits are set to become significantly more advanced, addressing both the challenges of deep space exploration and the practical needs of astronauts. Key developments will center around enhanced mobility, improved materials, and smarter systems integration. One of the most anticipated innovations is the use of wearable technology, which will allow astronauts to monitor their health and suit performance in real time. This could include sensors that track vital signs, environmental conditions, and suit integrity, all displayed through augmented reality within helmet visors. Materials will also become more advanced, with self-healing materials being developed to repair minor damage autonomously, increasing the longevity and safety of suits in space. Adaptive insulation is another area of focus, allowing the suit to adjust its thermal protection based on the environment, which would be particularly beneficial in extreme environments like the Moon or Mars. For Martian exploration, spacesuits will require more robust radiation shielding to protect astronauts from the intense cosmic rays and solar radiation on the Martian surface. There's also exploration into integrating robotic exoskeletons within the suit to help astronauts conserve energy and perform physically demanding tasks in Mars' lower gravity. Moreover, the next generation of suits will feature highly flexible joints and lightweight materials, ensuring greater freedom of movement for tasks that demand dexterity, such as scientific experiments or repairs in space. NASA's Smart Suit concept exemplifies this by incorporating soft robotics and sensors, making the suit both intelligent and mobile. As space missions push into more hostile environments, spacesuits will need to evolve further, focusing on autonomous systems that reduce the need for constant ground support, enabling astronauts to explore with increased independence and safety. That was it for today. Let us know your thoughts about today's comparison in the comments below. And if you want to know more about travel to space, don't forget to watch our video on wormholes, the key to interstellar travel. See you in the next one. Bye.